Yeah, hi everyone. Welcome to Numpy 2. So today we'll discuss about um, these things, which is first thing is converting 1D array to 2D array. Then we'll look at transposing, which is basically converting rows to columns and columns to rows, transforming, and then 2D array indexing. So how do we access elements from 2D array? Then slicing in 2D arrays, which is basically extracting subarrays from the array, and masking in 2D arrays. So how do we filter elements from a 2D array? Then, so NumPy aggregate functions. Aggregations are basically like summarizing the data, something like what is the minimum in the list or maximum in the list, sum of the complete list, etc., etc. And then yeah, logical operations. This is basically if we want to check if the entire list, if we want to perform like Boolean operation on the entire list. Say suppose if we want to say if the entire list values are less than say a particular value like 6, how do we get that? Or if all the values are less than 6 or any one of the values less than 6, we can, so we check using these logical operations. Yeah, then we update arrays using masking. So we can say based on the Boolean array that we get from the masking, how do we update a particular portion of the list or maybe the entire list as well. And we'll do small EDA, which is basically exploratory data analysis. This is the stuff that data analysts, data scientists, we all do to find some patterns and make some informed decisions. So that's the agenda. Let's begin. So first one is converting 1D to 2D array. So let's take let's do the basic stuff. Import numpy as np. Then let's create an array of 9 elements. Now one thing to remember, okay, let me just introduce the function. So we use np.reshape and this reshape, if we look at the documentation, reshape takes two parameters. So it takes two arguments. So the first one is if we want, so the first one we can say rows and columns. Think of them as say I want to convert 9 elements into rows and columns, which would be, let's say 3, 3. So we do array dot reshape 3, 3, and we put this into array 2. If we look at the shape of it, that is 3, 3. If we look at the shape of array, that is a single dimension, and that got converted to 2 dimensions. The things that we should remember are the elements have to be like the elements have to match exactly, in the sense that you cannot do something like 3, 2, that would throw an error. It has to match the elements exactly, or if you don't know how to match them, you can just set the second element as second argument as -1, and it will automatically calculate. So Numpy will automatically adjust the elements to fit it perfectly. So it cannot be greater than this one because 5 3s are 15 and we only have 9 elements. So that won't work. If we do 3 comma 2, that's 3 into 2, that is 6, which is less than the given number, so that also won't work. So one of these two arguments has to be -1. Both of them again cannot be -1. You have to specify at least one of them. So if we do 4, that also won't work. So it's a balance that you have to keep in mind. So that's about reshaping, which is converting 1D to 2D array. Let's look at transpose. Transpose is just converting, like transforming rows to columns and columns to rows. So the method is really simple. So you just have to do. Let's take the same example. So we have a 2D array. Dot. We just have to do a T, and that would transform. So if you look at the original one, so we have 0, 1, 2, 3, 4, 5, 6, 7, 8, and that got transformed to 0, 3, 6, 1, 4, 7, 2, 5, 8. So the row became column, and that's what it is. And we can transform it again to get it to the original array, which is basically rows to columns, columns to rows. So that's for transpose. Let's go to 2D array indexing. So let's take the same thing. So if you want, like in standard, we can do it the standard Python way, which is basically get the row and get the column value. So select the row. If we take the row, let's say I want the second element from the second row. So let's say we want 0, 1, index 1, column 1, row 1, column 1, which is 4. So this is one way. There is another way, which is we can specify rows, comma, columns. So that would be array 2. So we can take same row 1, column 1, and that would still give us 4. So if you want, say, the third row, second column value, so we can specify it as 2, which is third row, and second column is again 1, which is 7. So we get 7. We can also give list of indices in the as the arguments here. That would get us specific list of values. So suppose we want to fetch the diagonal elements, which is 0, 4, and 8. 0, 4, 8. So if we want to fetch the diagonal elements, then we can specify something. We can do something like list of row list, and we can do a column list. So let's specify the row list. Row list would be, we want row indexes. So index list. So the indices that we want are, we want the, so we have to select 0 1 2, because these we want the diagonal from these rows. So 0 1 2, and we can specify the column values. First row, first column value, which is 0. Second row, second column value, which is 4. So the index item would be 1, because 0 1. And then the third row, third index value, which is 2. So we got 0 4 8. So that is 2D array indexing. Now let's look at slicing. So let's take the same array, just to save time. So 2D, right, so slicing in 2D arrays. So suppose we want to so let's look at the syntax first. So you have the set of rows and columns. So if we want to slice them, we can set the start stop for this. So if we do this, we get all the values. If we want just if we want to fetch the first 2 rows and all columns, then we do first 2 would be 0 to, we don't even have to specify, so 0 to 1, which is the second index, and all columns. 0 so 0 1 2, it's 0 to 2. Okay, it is 0 to 2. So first 2 elements, and right. So 2 is so the this is excluded, right? So it is 0 to 2. The end is excluded. End is excluded in slicing. So it's not 0 to 1, it's 0 to 2. So if we want to fetch the first 2 columns, all rows and first 2 columns, we can do something like array 2, all rows and first 2 columns would be again 0 to 2. So which would take indices 0 1. So as you can see, 0 3 6 1 4 7. If we look at here, 0 3 6 1 4 7, these are the first 2 columns. Again, we can do one final thing. Let's say first row, we only want first row and second column, suppose something like that. So array 2 first row, which would be the just 0, which would be to 1, so 0th index, and second column would be we don't want first column, so we have to start from 1, which will take the first one, and no, we have to start from 0 1. Yeah, second column is 1 1 2, so we can say 1 to 2. Right, so first row, which is this, and second column, which is 1. So that is so that's all there is to slicing. And let's look at masking.
12 p.m. 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 12
Right. So right. So the this is same as 1D array. The only difference is um, if you if you filter in 2D array, you will get a flattened list. You'll get a flattened 1D array. Suppose let's take the same example. Say we want to filter all elements less than 6, a very standard example. Uh, so what we can do is let's check the Boolean list array2 less than 6. So it's giving us true, 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 true. So till here. So all of these values we get for less than 6. So now let's try to extract them. So as you can see, the 2D array became flattened 1D array. That is all there is to Boolean masking in masking in 2D arrays. So we can set more complicated conditions as well. So say less than 6 and the values are even. Say suppose mod 2 equal to 0. So we get all even values. So 0, 2 and 4. So that is all there is to masking in 2D arrays. Let's look at Numpy aggregate functions. So aggregate functions, common aggregate functions, we have min, max, which is common thing. We have sum, and we also have mean. We'll look at these 4 today in this lecture. So basically np dot, yeah, let's use the same array. So first thing would be np dot, we'll look at mean. So if we take the mean of the array, we'll get 4, which is sum of terms by number of terms. So if you see 8 plus 7 15 plus 6 21 26 plus 4 30 33 35 36 36 by 6 6 36 by 36 by 9 9 fours 36. So mean is 4. So that is mean. So if you look at np dot sum arg2, which is 36, that is correct. We look at np dot min is 0, and similarly we have np dot max is 8, which is correct. Now if we want, so there are we have different ways of performing these operations. So if we want to get the mean along the horizontal axis, so we want to get the mean along this axis, we can check that as well. So if we look at the documentation, if you look at the arguments, we can pass the array, which is the first parameter. We can also pass the axis. So if you saw the first lecture, Numpy 1, I have described, like I have explained the axis thing. Let me just refresh your memory once again. So axis is, so say we have a 2D array. Give me a moment. So we have a 2D array 0, 1, 2, 3, 4, 5, 6, 7, 8. The axis for a 2D array would be the vertical axis or we can also call it axis 1 is basically axis 0. It's basically axis 0. It's also called as first axis. The horizontal axis, it's also called the second axis, and it is called axis 1. So we set the argument as axis 1. Vertical is axis 0, horizontal is axis 1. If it is a 3D array, you will have length, width, and depth as well. So in that case, you will have vertical axis as axis 0, horizontal axis as axis 1, and the depth would be axis 2. If it is a 1D array, say you have 0, 1, 2, 3, you only have one axis, so the default axis is axis 0. So you should not confuse this horizontal direction with 2D arrays and 3D arrays horizontal direction. In 2D array, the horizontal direction would be axis 1, and the vertical direction would be axis 2. It's a direction. It's the direction in which you perform the operations. So let's check the example. So if we set the mean as array 2, and suppose we give axis as let's take horizontal axis, which is axis 1. So if you see, the mean becomes 5 plus 4 9 plus 3 12. 12 by 3 is 4. So it is summing these 3 elements and then dividing by 3. So you have 3 by 3, which is 1. That's correct. And then you have sum of terms, which is 5 plus 4 9 plus 3 12. So 12 by 3 elements, which is 4. That's correct. And then you have 8 plus 7 15 plus 6 21. So 21 by 3 elements, which is 7. It's also correct. So that it is doing the mean horizontally. If you set the axis to 0, it will do it vertically. So if you see 6 plus 3 is 9, plus 0 is 9. So 9 by 3 is 3. And if you have if you check the second column, 7 plus 4 is 11, plus 1 is 12, 12 by 3 is 4, and then you have 8 plus 5, 13 plus 2, 15, 15 by 3 is 5. So that is axis, and you can do the same for sum as well. So if you look at the vertical sum, which is 6 plus 3 is 9, 7 plus 4 plus 1 is 12, and this is 15. The same rules apply to min, max, all of them. So if you look at the max along the vertical direction, the max value is 6, max value is 7 for second column, and max value is 8 for the third column. So that is all there is to aggregate functions. Now let's look at logical operations. So in logical operations, you have two things, which is np dot any and np dot all. The idea for np dot any is we want to check if any of the elements in the list are, let's say, matching a particular value or less than a particular value. Say suppose let's take the same array. So the return value for np dot any is a boolean. So we use it for logical operations. So something like if np dot any array less than 6, then print yes, else print no. So if we do this, we get yes, because we do have less than 6, right? So 0, 1, 2, 3, 4, 5. So it is used for something like this. So we can do the same for all as well. So if you check for all of them, are all the elements in this array less than 6? That is false. So this will give no. So we get the answer as no. So we can check something like if array dot all let's take a different array. Let's take array 3 equal to 0, 0, 0. So we can say if all arrays in array 3, all elements in array 3 are equal to 0. That will print yes, because all the values in this are 0. So that's the basic idea in this one. There is one more way of doing it, where we can compare multiple arrays which we can do something like say if array 2, let's say array 2, which is this one, if array 2 is greater than array 3. So what we are saying is if 0, 1, 2, 3, 4, 5, 6, 7, 8 is greater than 0, 0, 0. So I guess we need let's take np dot zeros 9. Before that, let's just run this once again. So we have zeros. I guess let's take t type. Yeah, so what we are going to check here is if array 2, which is 0, 1, 2, 3, 4, 5, 6, 7, 8 is greater than these 0 values. Okay, I guess we need the same so we have two 2D arrays, and we are saying if this is greater than this array, the condition should be true, and if array 2 I guess we can check for this dot all. Yeah, this is false because we have a 0 here, right? So one of them becomes false. So what we can do is let's say that arrange start would be 1, stop would be 10. That became true. So all values in this one are strictly greater than the second array. So this is multiple array comparisons that we can do, and the result is a boolean. So we can check the same condition here. It returns a boolean value. The answer is yes. So you can say greater. Not greater. So they are strictly greater, and we can similarly do any. And when we do any, it still is greater because one of these values, I mean all of the values are strictly greater. We can check, we can reset this to for any, we can check a different condition, I guess. Let's see, array 2 greater than array 3 and let's do it here, array 2 greater than array 3 and array 2 make sure we add clarifying parenthesis, and the answer is still yes, because we do have some of them. It is there. So that's how you do logical operations. Then let's go to, so update arrays based on masking. So there are two ways we can do this. One is using the standard array less than 6, then set it to some value. The other way is we can use np.where. We give a condition, that's a special method, and then if the condition is true value and false value based on the condition. So let's look at the first scenario, which is pretty straightforward, nothing too fancy there. Look at the same 9 same array. So we can set something like array to array 2 right. So let's replace all values less than 6 to 1 or 0 or 1. So we can do something like array 2 less than 6, we can assign it to value 1. So if we check array 2 now, you see all values less than 6 until here, all of them are set to value 1. So this is one way of updating. You can set it to -1, anything, the standard update operation. Now we can use np.where. So if we look at the documentation for np.where, so it takes 2 of them, 2 arguments, and so if you see we set the condition in the first argument, and the second argument takes the true value and the value when the condition is true and the value when the condition is false. So we can say if array 2 less than 6 set it to 1 when the condition is true, and if it is false, then we'll just set it to none maybe. Let's check what happens. So one of the advantages is this creates a new array, which is basically, it's called array 3. It creates a copy. So as you can see, all the values that are true are set to 1 and that are false are set to none. Can we ignore this? Let me check once. No, we cannot. We have to set some value. Let's set it to none. So you can say that's one drawback for this one, because you have to define the else condition as well. So that's as far as updating based on masking goes. Now let's look at something called EDA, which is basically exploratory data analysis. Okay, so this is something all data scientists, data analysts do. To the fundamental idea is you study the data that's given to you, then you summarize it. You can summarize it using like mean, median, mode measures of central tendency or standard deviation, and then you visualize the data. So basically using charts and graphs. The whole purpose is to you want to find patterns within the data and then make some informed decisions. So suppose you are hired as an analyst in a firm, and you want, and their ask is they want to increase the revenue, let's say for the next quarter or something like that. So they want you to go through this data and tell them which product maybe to create, or which product we have to increase the advertising budget so that the revenues increase. So that's the gist. That's basically how it works. Now, this process is you can do this better in pandas than Numpy, but Numpy also has, although Numpy has Numpy is super useful, but loading the data and summarizing the values, you have much more handy functions in pandas. Give me a moment. So you have so we'll be looking at Fitbit data, which is the Fitbit watch. We'll look at the steps to the mood correlation. If there is any correlation between the number of steps that a user took, which actually affected his or her mood based on the number of steps he took. I already have a data set, so I will we can import the data set using np.load.txt. The file name is fit.txt, and let's check the data. Here we could not convert string to float at row 0. Okay, so generally these there are multiple types of data in here, and it is generally good to convert all the data into strings first, and then convert them separately later on. So we got the data here. we have to now, so this is the data. So the very first things that you have to do when you load the data is check for the data types, what type of data you have, and how do you want to convert it so that you can perform your analysis. Then look for nulls. This stuff we won't be doing in this lecture, but this is the general this one. We look at shape of the data, then the number of dimensions, and yeah, all this stuff. So let's look at the shape. Data dot shape. We have 96 rows and 6 columns. So 6 columns. Columns are basically features in data analysis. That's how you call it. Data dot and so it's a 2D array, right? So let's see. We have date, step count, mood, calories burnt, hours of sleep, and whether they're active or inactive. So again, let's look at one of the records just for observation sake. This is one record, and we have 6 features. So let's extract all features. So what do we have? Date, step count, mood, calories burned, hours of sleep, active. And the way we can do it is we can do data dot transpose. Since it's a 2D array, if we do a transpose, the columns become rows. So we can directly extract these 6 rows into these 6 variables. So if we check date, we got all dates. There is also another way of doing it. We can so say let's, before this step, let's try to do one thing. We can obviously do it the standard way. We can get all rows because we want all the records and the, say, first feature, we get all the dates. Second feature, we get all the step count. Third feature, we get all the moods. So this is one way of doing it, but this is quite quick, as you can set all of them at once. So we got all the dates, we got all the moods, we got all the step counts, calories burned, etc., etc. So now you see, we can't do much with strings here. So what we have to do is we have to convert to proper data types. So we'll convert dates to dates, but we won't be working with dates now. So let's convert step count for now. So we can say step count equal to np.array step count d type. Convert this to ints. So we got all the ints now. So as you can see here, okay, that got transformed. Let me run it once again. So we have all the step counts as strings here. D type U10 means every element here has a Unicode value of 10 bytes each. So each value has 10 bytes allocated to it, and we are now converting these strings to integers. The same thing we'll do with step counts, and we want to what else do we want? We want the step count. What else we'll look at? Calories burned, hours of sleep. I don't think we need any other thing for this demo. I'll just showcase just a small thing. Let's try to extract. So we have step count and mood, and the objective is find if these both, check if these both are correlated. So we want to find some relationship between these two features. So so let's say get step count of all of mood step count when mood is happy, sad, and neutral. So before that, let's see, check types of moods. Let's see how many moods are there, what types of moods are there. Moods. So we can use a function called np.unique. So we have 3 moods, which is happy, neutral, and sad. So let's get the step count. Get step count when mood is happy. So we know the standard filtering. So what we can do is data mood equal to happy. Now this works because we have a one-to-one relationship with the index, right? So we have the same, the step count has the same index as the mood. So here mood is neutral, you have the exact step count for neutral. So this filtering actually works because let's just check the Boolean array first. So you have trues here. So this exact indexing value we want. So happy, let's look at happy. So this exact index we will get. Yeah, I guess I don't have to explain so much. Let's look at data mood. Actually, we should check not data. We should check the step count. Step count when mood is happy. So these are the step counts when mood is happy. Let's do a mean and see what is the average step count when mood is happy is 3,392 steps. Let's do the same for sad. What is sad? Sad. When they are sad, the average step count is 2,100 approx, and when they are neutral, the average step count is about 3,153. So from this itself, we can conclude that, in one way, we can conclude that people are more happy when they run more, when they have a higher step count. Let's look at check if beyond count is beyond, let's say we have the average as 3,300, right? So let's say beyond 4,000 step count, what is the mood? So we can check this one with the same function. So np.unique, we can set the filter. So we want to check the moods and their respective counts of the moods. Excuse me. So mood mood when step count greater than 4,000. And we do have special another parameter as well. So if you look at the documentation, return counts. So what does this return counts do? Let's see. So return counts, what this does is if it is true, return the number of times each unique item appears in the array. So what happens is, let's see. So return counts is true. So as you can see, what this does is it checks the number of times. So we are checking if check all the moods when step count is greater than 4,000. So we got 3 moods when step count is greater than 4,000, and we have 22 times they are happy when their step count is greater than 4,000. So what this means is users are more happy when their step count is greater. So that's how we can say that's the relationship between the mood and step count, and we can conclude that users are happier when they run more or when they walk more. So that's it for today. That's it for Numpy 2. I'll see you in the next one.